Hi, I'm Mike Seeds, and we need to talk about orbital motion. That's a key to astronomy. Isaac Newton's most important work was done about 35 years after Galileo published his book, saying that the planets circle the sun. Newton's insight was not based on ancient theories, however. It was based on his careful observation of the world around him, and his careful thought about how things, as simple as a falling apple, actually work. You know that Newton did a bunch of wonderful things like discover gravity and invent calculus and so on. But for astronomy, the most important thing he did was explain orbits. Galileo said things move around the sun because that's what they did. Newton said they moved in orbits because of gravity. Newton understood orbital motion mathematically. But to explain it to readers of his book, he drew a cannon on a high mountain above Earth's atmosphere where there was no friction. If you put a little gunpowder in your cannon and fire it, the cannonball doesn't go very far. If you add more gunpowder, the cannonball goes farther. If you put in enough gunpowder, your cannonball will go so fast it will be in orbit. It is pulled by gravity toward Earth's center, but you gave it such a high horizontal velocity, it misses Earth. Continuously all the way around its orbit, it is falling toward Earth and missing. After about 90 minutes, it will come all the way around, and it'll blow your cannon to pieces, so look out for that. The velocity you need is called circular velocity. If your cannonball is high enough above the atmosphere to avoid friction, and if it doesn't hit your cannon first time around, it will fall in its orbit forever. You enjoy the benefits of orbital motion every day. Communication satellites and weather satellites are put into orbits 42,230 kilometers from Earth's center. At that distance, circular velocity carries them around Earth in 24 hours. If they orbit eastward, then they stay above the one spot on Earth's equator, and TV signals sent up to the satellite can be broadcast back to your satellite dish. Because Earth and the satellite both turn eastward every 24 hours, your TV dish never has to move. The satellite is always right up in your southern sky above the equator. These orbits are called geosynchronous orbits because the satellite's orbital motion is synchronized with Earth's rotation. Communication satellites, weather satellites, and some spy satellites are put into geosynchronous orbits. You can understand orbital motion by thinking about the motion of the moon around Earth. Newton's first law says that an object in motion tends to stay in motion in a straight line unless it is acted on by some force. If gravity didn't pull the moon toward Earth, the moon would sail away in a straight line and never return. It's Earth's gravity that continuously pulls the moon away from straight line motion and forces it to follow a curved orbit around Earth. So the moon is falling. Every second it falls about 1.4 millimeters toward Earth, but its circular velocity means that it continuously misses. Actually, Newton showed that the moon doesn't really orbit Earth. The Earth and moon orbit their common center of mass, their balance point. Earth is so massive the center of mass is inside Earth, so the moon, being much less massive, is farther from the balance point and follows a larger orbit. Earth is so massive it hardly moves as it circles the center of mass. Some pairs of stars orbit each other, and because they are similar in mass, they both follow larger orbits, keeping the center of mass on a line connecting their centers. You might be wondering what would happen if you didn't put in quite enough gunpowder. Then the cannonball would not quite reach circular orbit. It would go into an elliptical orbit that would allow it to come closer to Earth halfway around. If you put in a little bit too much gunpowder, your cannonball would go into an elliptical orbit that would carry it higher above Earth at the halfway point. These elliptical orbits can be stable if the cannonball never enters Earth's atmosphere. But what happens if you give the cannonball just enough velocity to escape from Earth and never come back? That's called escape velocity, and its orbit would be a parabola. If you gave it even more velocity, it would escape along a hyperbola. Newton showed that these closed elliptical orbits and the open escape orbits are all related mathematically. Today, astronomers recognize orbital motion as the natural result of Newton's three laws of motion and gravity.